Hello everyone. In this video presentation, I will be speaking about how some aspects of mechanical engineering can contribute to exploration and development of the Arctic. First of all, I would briefly introduce the natural resources of the Arctic. Next, I will discuss the challenge of exploration on the Arctic and the solution to it. At last, I'm going to talk about development of the Arctic, especially offshore drilling and shipping. U.S. Geological Survey in 2008 estimated that 90 billion barrels of oil, 1,670 trillion cubic feet of natural gas, and 44 billion barrels of natural gas liquids may remain to be found in the Arctic. That is to say, 22% of the world's oil and natural gas could be located beneath the Arctic. BP reveals that in 2013, the total world proved oil reserves is only sufficient to meet 53.3 years of global production, and the Arctic, with huge hydrocarbon resources, has drawn attention. In addition, Greenland holds about 10% of the world's freshwater reserves. However, in this presentation, I mainly focus on the hydrocarbon resources located beneath the Arctic. The exploration on the Arctic is very difficult and dangerous. One main challenge of the exploration on the Arctic is surface roughness and near-surface heterogeneity. In-ground with permafrost and seasonally frozen layers, there are often abrupt transitions between the frozen and melted zones. These transitions usually result in large and rapid variations, both vertical and lateral, of elastic properties, and that is why cargo trucks often break through the ice crossing the river. To solve this problem, a special vehicle is invented. Mechanical engineer in Western Jico designed a rubber-tracked, low-ground pressure vehicle. These vehicles have wide rubber-treaded tracks and a new drive system. When making a turn, conventional tracked vehicles lock one track while keeping the other moving. They lock the tracks along the ground, often causing the damage. With the new drive system, both tracks continue to move during a turn, but one of them moves faster than the other, reducing potential damage to the soil. Drilling in the Arctic includes two components, onshore and offshore drilling. In this video presentation, I will be speaking about the techniques that is used for offshore drilling, which is the offshore deepwater drilling process. Offshore drilling is similar in many ways to drilling on land. Like their onshore counterparts, offshore rig crews use drilling mud and rotary drill bits to bore a hole into the earth. Drillers pump the mud down through a drill pipe that connects with and turns the bit. The mud flows out of holes in the bit and then circulates back to the rig through the space between the drill pipe and the sides of the wheel. As it flows, the mud coats the bit and carries polarized rock called cuttings away from the bottom of the wheel. When the mud returns to the surface, rig equipment sieves the cuttings out and pumps the mud back down the drill string. The mud thus travels in a closed loop. As for shipping, Northern Sea Road makes the voyage from Asia to Europe shaves roughly 30%, which also avoids pirate-infested water. For a mechanical engineer, designing a cargo ship with a structure as an icebreaker will gain huge profits. In conclusion, in order to claim how some aspect of mechanical engineering can contribute to the exploration and development of the Arctic, I firstly introduce the hydrocarbon resources, including oil and natural gas on the Arctic. Then, I discuss one of the challenges of the exploration on the Arctic, which is the danger of thin ice and how mechanical engineers solve the problem. In the end, I mentioned the development of the Arctic by introducing the offshore deepwater drilling process and develop Northern Sea Road shipping.